Hey, today marks another attempt at building a motor controller because I'm dissatisfied with those golf cart controllers. They're not going to give me enough power. So I'm going way back to where I started when I built a motor controller which basically burned out under load. And I'm going to try and build one that won't burn out under load. Today's task is to try to get my Arduino to create pulse width modulation of a duty cycle that different chips will accept. Okay, I just wanted to show you this again. After much farting around, there's the serial monitor running an Arduino. You can see the throttle is at 0. As it advances now all the way up to the top, the PWM pin is now tracking with it appropriately. 255 is the max. It's getting to 253, so I think that's good enough. And now if you see, drop it back down to 0, put it on the scope, that's 0. Moving it up, you can see the top bar is the percentage of the duty cycle. So now that is, as we're moving to full, it's almost a solid bar. Just a tiny bit on the bottom. Slow it down again. That's half throttle. Quarter throttle. Stopped. So it's the Arduino is now doing what it's supposed to do. So I set up this little baby oscilloscope here as well to show you how the waveform is affected as I move the throttle connector or the throttle control. Right now it's at 0. As I move it up, you can see the vertical bar getting wider and wider. That's the duty cycle that's being fed. So as I move to the top of the thing, you can see that it's almost completely solid. It's 100% duty cycle. And as it drops down, it's about 50%. 50% on, 50% off. And back down to 0. All right, next phase. We're now in my freshly cleaned up shop until I clean it up just for you guys. It's looking good. The next step is to take the Arduino, now in a clear plastic box, and the code we perfected, and route it such that the Arduino gives a feed to this HCPL 3120 chip. And what that is an optical link. The signal from the Arduino causes a tiny little LED inside the thing to flash and flash, which is then picked up by the powered side and basically amplified. The PWM signal is coming in from the right hand of your screen, going into the chip. An LED is flashing. It's being picked up by the second half of the chip and then sent on. All right, we're back. It's the next day. I cleaned up the shop some more. It's almost antiseptic in here now. I have made another change of plan on the principle that simplifying a machine makes it better. If you eliminate everything you can, it's a better thing. I decided not to put that second chip in daisy chained. I'm just going to go with the HCPL 5120. And lordy, it's working. There's my Arduino sketch. And you can see the serial monitor. Right now everything's set to 0. It sends the pulses over to the IGBT, which I also have the oscilloscope hooked up to. Right now it's at 0. You can see that as I turn up the throttle, the little motor starts to spin. I'm running 30 volts through a 12 volt motor, so that's kind of fun. Does work. Put it at half throttle. You can see the duty cycle on the oscilloscope. You can see the serial monitor vary up and down depending on the throttle position, and everything seems to be working. The only problem I'm finding immediately is this little resistor, which you need to use, is super overheating. So I need to upsize that to something that handle more wattage. That's about to blow any second, but for now it's working. Again, there's the oscilloscope. That's probably about a 15% duty cycle. Get the reflection out of there. Turning it up, turning it up. So I have a motor controller. Will this scale to a full-size car? Who the hell knows? Good morning. I have placed all of the control unit stuff inside of a box which will hang somewhere in the engine bay of the car. It has two discrete power supplies, both of which are powered by a 12-volt battery, what I'm calling house power in the electric car. 5 volts feeds the Arduino. 15 volts feeds the HCPL3120. And we have input of the throttle controller. And right now the output is the oscilloscope. And you can see now as I move the throttle up from 0, we get a bigger and bigger duty cycle all the way to 100%, and then back down to 0. So the control circuitry, it's sending pulses. Now yesterday I had a bit of an event. The resistor I was using, a 10 ohm resistor, was heating up badly. So I went ahead and put in a higher wattage 10 ohm resistor. Exactly the wrong thing to do. I think I blew up the IGBT. And then the HCPL3120 chip, that little black devil there, that burned up too. So now I'm running my spare chip, and I'm going to throw in a different IGBT later today to make sure that it's now working. I now have an 18 ohm resistor there. Hopefully that will work. Okay, this will be the last clip for this this round, for this video. I did manage to troubleshoot the battery hookup. I now have 85 volts coming over to the new IGBT. Here's the old one. Still works, but not powerful enough. I have everything hooked up. I have the snubber capacitor hooked up. I have the oscilloscope hooked up. I have Arduino running. I have everything powered. I have it hooked up to my larger battery, and I have a great big honkin' capacitor to smooth out the current flow, especially when you take off power. And the result is everything works. So the one last thing is this. If all this screwing around has taught me anything, it's that the specific combination of voltage, the IGBT, the characteristics of the motor itself requires tuning. Tuning of the frequency, tuning of the resistor in the gate circuit that triggers the IGBT. And I have no idea how all this stuff is going to work with the big honkin' motor. Now I could take this battery box and install it in the car and run the cables and everything, and then install this motor controller and test it there in the car. But I think unless I got really lucky, it might not work. It might not work optimally. So what I'm thinking I need to do, what just beeped, is uninstall the forklift motor from the Volvo, bring it over here, put it in a cradle, and continue with what I'm doing here with the big motor until I have it responding the way I think it needs to respond. And I have to be sparing about that because you can't run a big motor like that without load. It's bad for them. But I can at least run it up the top and run it back down again. Make sure that it isn't stuttering or acting weird or having flat spots or falling off at the top. All the weird behaviors I've seen with these other motors and these other IGBTs. So as much as I hate to do it because I got that thing in the car and balanced, I'm going to take it out and bring it over here. So it's going to add a little time to this to this project, but I think it will save me work in the long run. So that'll be the next video, me tuning the big motor here and then maybe showing me reinstalling the motor and this other stuff. So thanks.